Our topic is polynomials. Before discussing polynomials, let's understand what do we mean by monomial. What do we mean by monomial? A monomial can be constant, variable, a product of constant and a variable, or more than one variable, with the variables having only non-negative integer exponents. Non-negative integer exponents. They should be always positive. Okay, this is called monomial. That is, a monomial is a constant, a variable, the product of constant and one variable or more variables, with the variables having only non-negative integer exponents. For example, 3x to the power minus 2 is not a monomial, okay? This is because we have negative integer as the exponent, okay? So a monomial always should be positive in order to be a monomial. What is the degree of monomial? It is the sum of exponents of the variables. For example, we have 7y minus 12a squared bc cubed and minus 8. So what is the degree of each monomial? The degree here, since this is to the power 1, so the degree is 1. Okay, this is the degree. What about this one? We mentioned before, it is the sum of the exponents of the variables. Okay, so if you add the exponents of the variable, we have here 2, we have here 1, and we have here 3. So our answer should be 6. The degree is 6. Okay, the degree is 6. What about this one? What is the degree of this one? It is like if you multiplied it by x to the power 0. Okay, so x to the power 0 is 1. Minus 8 multiplied in 1 is minus 8. So the degree of this monomial is 0. Now if I take several monomials, minus x, 7y, minus 12a squared bc cubed, and minus 8, and I ask you what is the numerical coefficient, or simply the coefficient. The coefficient is simply the constant multiplying the variables. Okay, so what is the coefficient in the case of minus x? We know minus x is minus 1 multiplied in x. Okay, so the constant multiplying the variables, so the coefficient of minus x is minus 1. Okay, also what is the coefficient of 7y? So it is the constant that multiplies the variable. What is the constant multiplied the variable? Is 7. So the coefficient here is 7. Here coefficient is minus 1. Okay, so in case of minus 12 a squared bc cubed, so the constant that multiplies, that is multiplying the variables, is minus 12. So this is the coefficient. Okay, the constant. What about minus 8? minus 8, there is no variable exists, so we cannot say there is a coefficient. In fact, this is called a constant. Okay, minus 8 is constant. Okay, now having knowledge about monomials, we should now define a polynomial. A polynomial is the sum of a finite number of monomials. Again, it is a sum of finite number of monomials. Finite, you can say 3 numbers of monomials, 5 numbers of monomials, 100 as a number of monomials. You cannot say infinity number of monomials. If there is infinity number of monomials, then it is not a polynomial. So should be a finite number of monomials. If it is not monomial, for example, if I say x to the power minus 1, this is not a monomial. Then it should not compose a polynomial. A polynomial shouldn't have a negative degree. Okay, each monomial in the polynomial is called a term of the polynomial. Also, the degree of a polynomial is the greatest of the degrees of the terms or monomials. For example, if we have a polynomial which is 5x squared x to the power 4 minus 6x cubed plus 5x squared minus 7x minus 8. So, what are the terms of this polynomial? What are the terms or monomials of this polynomial? This is the first term. This is the second term. This is the third term. This is the fourth term. And this is the fifth term. So, also, what is the degree of the polynomial? We know that degree of the polynomial is the greatest of the degrees of the terms or monomials. Okay, we know also the degree of the monomial is what? Is the sum of the exponents of the variables in one monomial. Okay, so the degree of the polynomial is the greatest of the degrees of the terms. What is the greatest of the degrees of the term? Here the degree is 4, and here the degree is 3, and here the degree is 2, and here the degree is 1, and here the degree is 0. So the greatest is 4. So the degree of the polynomial is 4. Let's take another example. The polynomial, which is minus 3xy squared minus 8xy plus 6. What are the terms? This is the first term, this is the second term, and this is the third term. Now, what is the degree of the polynomial? We know it is the greatest of the degrees of the terms. So, what is the degree of this term? We know it is 3, because 1 plus 2 is 3. Okay. What is the degree of this term? It is 2. What is the degree of this term? Is 1. So the degree of the polynomial is the greatest, which is 3. Let me now introduce you to like terms. What are like terms? Like terms are those terms that have exactly the same variables raised to the same powers. That is, the terms that have exactly the same variables raised to the same powers. For example, 14x squared and minus x squared are like variables. And if we say 7x squared y and 5y x squared are also like variables. Why is that? Because they have exactly the same variables, here x squared and here x squared, okay? And raised to the same power. Here raised to 2 and here raised to 2. Okay? What about the other example? Here we have x squared y and here we have x squared y. X of course raised to the same power and y raised to the same power, which is 1 here in both terms. So these two examples are like terms. Like terms, okay? This is the first example, this is the second example. However, if there is, for example, 6xy squared and 6x squared y, they are not like variables. They are not like variables. Why is that? Because here we have the same variables, yes, here we have xy and we have here xy. However, x here is raised to the power 1 and here raised to the power 2. So this, and also y is raised to the power 2 and y here is raised to the power 1. So they are not like variables. They are not like variables. Even if I say 6xy squared and 6x squared y squared, y and here y, the same variable raised to the same power. So we are okay at y. However, x and x here, we have the same variables, but x here is raised to the power 1 and here raised to the power 2. So these two examples are not like terms. A polynomial is said to be in its simplest form when its all like terms are combined. For example, this polynomial is not in the simplest form. Why is that? Because not all its like terms are combined. Here we have like terms. For example, 4x squared and minus x squared are like terms. They are not combined. And here we have 3x and 5x are like terms. They are not combined. So what is the simplest form for the above polynomial? It should be when all like terms are combined. So 4x squared minus x squared is 3x squared. 3x plus 5x is plus 8x. Now we have the polynomial in its simplest form. Please note for your information that a binomial is a simplified polynomial with two terms. For example, 3x squared minus x. This is a binomial because it is a polynomial simplified with two terms. If I say to you also 5x plus 1, this is a binomial. A trinomial is a simplified polynomial with three terms. So let's give you an example of a simplified polynomial with three terms. Let's say 3x squared minus x plus 1. This is a trinomial. Also, if I say 5x squared minus x y plus 1, this is a trinomial. A constant polynomial is a non-zero constant. A non-zero constant such as 5 or 6 or 7. Those are called constants polynomials. Let me now introduce you to the standard form of a polynomial. What is the standard form of a polynomial? The standard form of a polynomial of degree n and the variable x is a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 plus up to you reach a 2 x square plus a 1 x plus a naught or a 0. Noting that this an is not equal to 0. Also, n is a non-negative integer. This means that n can take values such as 0, 1, 2, 3, 4, up to infinity. This an is called the leading coefficient. Okay, and this a naught or a0 is called the constant term. What do we mean by the standard form? I will give you examples to understand what do we mean by the standard form of a polynomial. Okay, here is an example of a polynomial in its standard form. We say 2x cubed plus 6x minus 7. It is in the standard form. Why is that? Because we started by the highest degree, which is 3, okay, and the leading coefficient is not equal to 0, and we are decreasing from degrees, because here it is the degree is 3 and here the degree is 1 and here the degree is 0, so you are decreasing, going from 3 to 1 and 1 to 0. Okay, another example, if I say to you minus 2z to the power 4 plus 4z cubed plus 3z minus 9. Okay, here it is in the standard form. Why is that? Because we started by the highest degree, which is 4 here, right? Here the degree is 4, here the degree is 3, and here the degree is 1. So we are decreasing from 4 to 3 and 3 to 1 up to 0, of course, which is here 9, constant, multiplied in x to the power or z to the power 0 whatsoever. Okay, so you are decreasing from the highest degree to the lowest degree. Also, an is not equal to 0, or the leading coefficient is not equal to 0. Another example, if I say y to the power 5 minus 3y cubed minus y squared minus 2y plus 1. This polynomial is in its standard form. Why is that? Because we started with the highest degree from 5 to 3 to 2 to 1 to 0, decreasing. Okay, we are decreasing. This is number 1. Number 2, the an is not equal to 0, which is here the leading coefficient, which is 1. Okay, so this polynomial in its standard form, and this polynomial is in its standard form, and this polynomial is in its standard form. Another example, minus 2x to the power 4 plus 6x cubed minus x plus 5. This is in the standard form, or this polynomial in the standard form. Why is that? Because we started by the highest degree, which is 4. Here it is 3, here it is 1, here it is 0. So we are decreasing. Also, Another condition should be satisfied where an is not equal to 0 or the leading coefficient is minus 2, which is not equal to 0. So this polynomial is in its standard form. Example, write the polynomial in standard form. Identify the degree, terms, constant term, leading coefficient, and coefficients of the polynomial. A, 2x plus x squared minus 7. We have to write in standard form. Identify the degree, terms, constant terms, leading coefficient, and coefficients. Okay? So this polynomial is not in standard form. Why is that? Because we started with the degree which is not the highest degree. For us to write in standard form, we should first start with the highest degree and go down until the lowest degree, taking care that the leading coefficient should be not equal to 0. So what is the degree of 2x? It is 1. What is the degree of x squared? It is 2. What is the degree of 7? Is 0, right? So in order to write in standard form, we should start with the highest degree and going down up to the lowest degree. So the highest degree is x squared and the leading coefficient is not equal to 0 plus 2x. We go down from 2, 1, then we go to 0, right? The degree which is 0. So x squared plus 2x plus 7. This is now in the standard form. So what is the degree of the polynomial? The degree of the polynomial is the highest degree, which is what? 2, of course. What are the terms of the polynomial? We have x squared, we have 2x, we have 7. What is the constant term? What is the constant term? Because we are having only one constant term should be. So this is not terms, should be term. Constant term. What is the constant term? It is 7. Okay. What is the leading coefficient? The leading coefficient is here, which is what? 1. What are the coefficients of the polynomial? 1, 2, and 7. Another example B, we have minus 3x squared minus 11 plus 12x to the power 4. So putting it in the standard form, we must first start with the highest degree. What is the degree of minus 3x squared? The degree is 2. The degree of minus 11 is 0. The degree of 12x to the power 4 is 4. So to start with the highest degree, going down to the lowest degree, provided that the leading coefficient is not equal to 0, this is the standard form of a polynomial. So we will write 12x to the power 4 minus 3x to the square minus 11. This is now in the standard form. So the degree is the highest degree of the polynomial, or the polynomial in its standard form. So it is 4. The terms, we have 12x to the power 4 minus 3x squared and minus 11. Constant term is minus 11. Leading coefficient is the coefficient multiplies with the highest degree, which is here 12. Okay. The coefficients of the polynomial, we have 12, we have minus 3, and we have the minus 11. We know that minus 11 is the constant term, or the coefficient of minus 11 multiplied in x to the power 0. So it is a coefficient, or you can call it a constant term as well. Another example, x cubed minus 1. Is this in the standard form? Yes, because we started with the highest degree, going down to the lowest degree and taking note that the leading coefficient is not equal to 0. So writing it down, x cube minus 1. It is in the standard form. So the degree is what? 3. The terms we have x cube and minus 1. The constant term is minus 1. The leading coefficient is 1. The 1 multiplies with the highest degree. The coefficients we can say 1 and minus 1. Another example, 4x squared minus x plus 7. Is it in the standard form? Let's see. This term's degree is 2. This term's degree is 1. And this term's degree is 0. So we are going down from the highest degree, which is 2, to 1 to 0. Therefore, this is written already in the standard form, right? So the standard form for x squared, provided that n or the leading coefficient is not equal to 0, minus x plus 7. It is in the standard form. The degree 2. The terms we have for x squared and minus x and 7. The constant term is 7. The leading coefficient is 4. The coefficients we have 4, minus 1 and 7. Another example, 2x to the power 4 plus 3x squared plus 5 plus 4x squared. Is this in the standard form? We first, when we look to the polynomial, we see that we have like terms are not combined. So this polynomial itself, it is not in the simplest form. Its simplest form is 2x to the power 4. 3x squared plus 4x squared is 9x squared, okay? Plus what? 5. So now, is it in the standard form? We have here the degree is 4, the degree is 2, the degree is 0. So 2x to the power 4 plus 9x squared plus 5 is a polynomial in the standard form, because we are starting with the highest degree going down to the lowest degree, provided that the leading coefficient is not equal to 0. So the standard form should be 2x to the power 4 plus 9x squared plus 5. The degree we have is, the degree for the polynomial is 4. The terms we have 2x to the power 4, 9x squared, and we have 5. The constant term is 5. The leading coefficient is 2. The coefficients we have 2, 9, and 5. Let's now take another example. Is this polynomial in the standard form? We see first the degrees. The degree of this term is 4. The degree of this term is 3. The degree of this term is 0. And the degree of this term is 2. So it is not in the standard form. Standard form we should go down up to the lowest degree. So we started with 4, 3, then 0. It should be here 2. So the standard form is written as this: 5x to the power 4 plus 9x to the power cube plus 2x squared plus 10. This is in the standard form. Here we started with the highest degree going down to the lowest 3, and we didn't go down to the second lowest. The second lowest is 2. It should be here, okay, before the 0. So the degree of this polynomial in the standard form is what? 4. The terms we have 5x to the power 4 and 9x cubed and 2x squared and 10. The constant term is 10. The leading coefficient is 5. The coefficients are 5, 9, 2, and 10. Example G, 3x squared minus 5x cubed plus 7x minus 1. Is it in the standard form? No. Why is that? Because here the degree is 2, here is 3, here is 1, and here is 0. So we should arrange our degree from highest to lowest. That is, we should start with degree 3, then 2, then 1, then 0. So our standard form should be minus 5x to the power 3 plus 3x squared plus 7x minus 1. This is the standard form. Okay, this is the standard form of the polynomial. The degree of the polynomial is 3. The terms we have minus x cubed and 3x squared and 7x and minus 1. The constant term is minus 1. The leading coefficient is minus 5. And the coefficients we have minus 5, 3, 7, and minus 1. That's it. Now let's discuss how to add polynomials, how to subtract polynomials, and how to multiply polynomials. The division will be discussed later. To add a polynomial, simply add the coefficients of like terms. For example, if we would like to add this polynomial to this polynomial, we add the coefficients of like terms. What are the like terms of those polynomials? We have here x cubed, and we don't have any x cubed here. Here we have x cubed in this polynomial, and we don't have any x cubed here. So another term, if we say we have x squared here and we have x squared here. Okay, so they are like terms. Also minus 6 and here minus 7, so they are like terms. All are here. For example, 3x cubed doesn't have any term in the other polynomial. Okay, but minus x squared, it has 4x squared, as these both are like terms, and minus x and minus 7 are like terms. So to add these two polynomials, this polynomial with this polynomial, we should add the coefficients of like terms. So 3x squared, 3x cubed will remain the same, minus 2x squared with 4x squared. So it should be plus 2x squared, and minus 6 with minus 7. So it should be minus 13. So now we have added the two polynomials. Let's take another example. If I say 5x to the power square minus 7x plus 3. Okay, this polynomial, if you add it to 2x squared plus 8x plus 1. How to add these two polynomials? We add first the like terms. We have here minus 5x squared, and we have here 2x squared. So we add them together. Also we have here minus 7x with 8x. They are like terms, so we add them together. And we have 3 here with 1. So they are like terms, so we add them together. So the answer should be 5x squared plus 2x squared should be 7x squared. And minus 7x with plus 8x should be plus x, because minus 7 plus 8 is 1, so 1 is not written. And plus 3 alone as a constant, and plus 1 when added should be plus 4. This how you add polynomials. Okay, what do? We add the coefficients of like terms. This is how you add polynomials. You add the coefficients of like terms. That's it for adding polynomials. Now, what do we do to subtract a polynomial, or to subtract two polynomials from each other? Okay? To subtract a polynomial, we add its additive inverse. What is the additive inverse of a polynomial? For example, if I tell you 3x minus 7, what is the additive inverse of 3x minus 7? You just say, as you remember, the additive inverse of a is minus a, right? Here, the additive inverse of 3x minus 7 is minus, between parentheses, 3x minus 7, which is eventually equal to minus 3x minus plus 7. So what did we do? We changed the signs. Of course, here we have positive and here we have negative. So we changed the sign. Positive, it transformed to negative, and negative transformed to positive. Any questions ask you, what is the additive inverse of a polynomial? You change the sign. For example, if I say 3x squared minus 8x plus 7, what is the additive inverse? Additive inverse of this polynomial. The additive inverse of this polynomial is, change the sign. 3x squared should be minus 3x squared. Minus 8x should be plus 8x. Plus 7 should be minus 7. So what did we do in order to get to this answer? We just said the additive inverse of 3x squared minus 8x plus 7 is negative of what is inside, the same. That's the same as a. The additive inverse of a is minus a, right? And the additive inverse of 3x squared minus 8x plus 7 is minus, between parentheses, 3x squared minus 8x plus 7, which is eventually this. You just only change the sign. Here we have positive, it transformed to negative, and here we have negative, it changed to positive, and here we have positive, it changed to negative. This is the additive inverse of polynomials. Going back, how to subtract polynomials, we add its additive inverse. For example, if a question comes to you and said subtract this two polynomial, 2x minus 5, this is the first polynomial, minus 3x minus 7. So how to answer that? As I told you before, we add its additive inverse. How this is performed? We say this is 2x minus 5 will remain the same. Now if you subtract, now we will add the additive inverse, which is minus 3x plus 7, the additive inverse of this one. Okay. So again, in subtraction, we add its additive inverse. So we add its additive inverse. The additive inverse of this polynomial is minus 3x plus 7. So we add it instead of subtraction. When adding, again, we add like terms. We have 2x and we have here minus 3x. And we have here minus 5 and here 7. So 2x minus 3x is minus x, or minus 1x, but we don't write minus 1. And minus 5 with plus 7 should be plus 2. Now this is the answer for subtraction. Another example, if I tell you subtract 3x squared plus 5x, this polynomial, from this polynomial, minus x squared plus x minus 1. If you subtract, you change here. You add the additive inverse. The additive inverse is what? Here minus x square, here minus x, here plus 1. We just only change the sign, and this will remain the same. 3x square plus 5x. Okay, now easy task to add these two polynomials. So these are the like terms, 3x square and minus x, and 5x with minus x. Of course, if you add, should be the answer 3x square minus x is 2x square. 5x with minus x should be 4x, and plus 1 will remain the same. Now we performed the subtraction. What did we do? We add its additive inverse. You can easily do that. You can easily do that if you have the question again. Let's say 4x to the power 3 minus 2x square. If you subtract from x cube plus x square. For me, what I do usually, I do like this. This will remain the same, 4x cube. Okay, without parentheses, because as you proceed in the future, you will know this automatically. 4x cube minus 2x square, minus multiplied in here and minus multiplied in here should be what? Minus x cube minus x square. We now add like terms, okay, and the answer should be here 4x cube minus x cube should be 3x cube, and minus 2x square minus x square should be minus 3x square. It is either way you can choose. However, in general, when we subtract polynomials, we add its additive inverse. Now let's discuss how to multiply polynomials. When we multiply polynomials, we use the distributive property. How is that? I will give you an example. We have this polynomial multiplied in this polynomial. What do? The distributive property. That is, we distribute by multiplying here 2x square into 3x and 2x square into 4. Also, we multiply minus 5x into 3x and multiply minus 5x into 4. Also, we multiply 3 into 3x and 3 into 4. So our answer should be 2x square multiplied in 3x should be 6x cube, and 2x square multiplied in 4 should be plus 8x square. Also, minus 5x multiplied in 3x should be minus 15x square, and minus 5x multiplied in 4 should be minus 20x. We complete 3 multiplied in 3x is 9x, and 3 multiplied in 4 should be 12. So we performed that distributive property. Now we add like terms. We have here x cube, and we don't have any other x cube, but we have here x square and we have here x square, so they are like terms. So completing our answer should be 6x cube plus minus should be 7x square. Now we added these two like terms. 20x minus 20x and plus 9x is, because they are like terms, should be minus 11x, and 12 is alone, so we will write it as it is, plus 12. Now we perform the multiplication. There is another way. Which is the vertical format. It is the normal multiplication that you are used to. For example, if you multiply these two polynomials together, the first polynomial is 2x squared minus 5x plus 3 multiplied in 3x plus 4. So the vertical format, you start multiplying 4 into 3 into minus 5x into 2x squared. So our answer should be 4 multiplied in 3 is what? This 4 multiplied in 3 is what? Plus 12. And 4 multiplied in minus 5x is what? Is minus 20x. And 4 multiplied in 2x squared is plus 8x squared. Okay. What about now 3x multiplied in 3 is what? Is 9 plus 9x. Okay. And 3x multiplied in minus 5x is minus 15x squared. And 3x multiplied in 2x squared is 6x cubed. When you add these two polynomials, this here 12 minus 20x plus 9x is minus 11x, of course here is plus, and 8x squared minus 15x squared is minus 7x squared. 6x cubed will remain the same. 6x cubed will remain the same. This is our final answer. So either way you choose, whether you choose the first, the distributive property, or you use the vertical property. For me, I will prefer, and from now on I will use the distributive property since it is easy to implement. Suppose I have an example says multiply polynomials. This polynomial multiplied in this polynomial. So how is our answer should be? Okay, of course we will use the distributive property. Okay, so we will multiply 2x into x cubed. Also we will multiply 2x into minus 4x, and we will multiply 2x into plus 2. Also we will multiply minus 5 into x cubed and minus 5 into minus 4x and minus 5 into plus 2. So our answer should be 2x multiplied in x cubed is 2x to the power 4, and 2x multiplied in minus 4x is minus 8x squared. 2x multiplied in plus 2 is plus 4x. What about minus 5? Minus 5 multiplied in x cubed is minus 5x cubed, and minus 5 multiplied in minus 4x is plus 20x, and minus 5 multiplied in plus 2 is minus 10. So now we add like terms. We have here 4x and 20x. So finishing our answer, putting it in the standard form, we start with the highest degree and going down. So the next one is minus 5x cubed minus 8x squared plus 24x minus 10, and we are done. Another question comes, 3x squared, this polynomial, plus 4x squared minus x plus 7 multiplied in 3x minus 2. How to do that? We first multiply 3x cubed into 3x, and 3x cubed also we multiplied it in minus 2. Also we multiply 4x squared into 3x, and 4x squared into minus 2. We multiply also minus x into 3x, and similarly minus x into minus 2, okay, and plus 7 into 3x and plus 7 into minus 2. So how is this performed? Solution. Using the distributive property, we will multiply 3x first here with 3x here. So the answer should be 3x cubed multiplying 3x should be 9x to the power 4. Also 3x cubed multiplying minus 2 is minus 6x to the power cube. Now 4x squared multiplied in 3x is plus 12x to the power 3, and 4x squared multiplied in minus 2 should be minus 8x squared. Okay, what about now minus x multiplied in 3x is minus 3x squared, and minus x multiplied in minus 2 should be plus 2x. Okay, what about 7 multiplied in 3x is plus 21x, and now 7 multiplied in minus 2, 7 multiplied in minus 2 here should be minus 14. Now we will add like terms. So what are the like terms? Here we have like terms, and here we have like terms, okay, and here we have like terms. Okay, so minus 6x cubed plus 12x cubed should be, before this will remain the same, 9x to the power 4. So again minus x cubed plus 12x cubed is plus 6x cubed, and minus x squared minus 3x squared should be minus 11x squared. What about 2x plus 21x is 23x. Minus 14 will remain the same. So we are done. Please note that there is a common method for multiplying two binomials. We know that binomial is a polynomial with two terms. Let's say a plus b. Okay, if you multiply it by another binomial, which is a polynomial with two terms, let's say c plus d, there is a common method. In fact, as we used before, we use the distributive property to multiply polynomials. Okay, so if we multiply a plus b into c plus d, you use the distributive property, then you are correct. However, there is a common method called the FOIL method. FOIL. FOIL method. What is the FOIL method? It is used when multiplying two binomials. That means two binomials or two polynomials with two terms each. Okay? This method, the FOIL method, made it simple for multiplying two binomials. Let's say that we have a plus b multiplied into c plus d. Okay, you can use the distributive method as mentioned before. However, there is a special case and a method for binomials. Okay, so what is this method? It is called the FOIL method. FOIL method. It is another form of distributive. So it is first, this F stands for first, and this O stands for out, and this I stands for inner, and this L stands for last. So what is the FOIL method? We start by F. This is first. This is called first. Then O, which means out. Okay, then we say out, and we say inner. So these are the inner. This is out, this is inner. Then there is the last. This is the last. So it is first, out, inner, last. FOIL method. So this is eventually equals to AC plus AD plus BC plus BD. Here first, out, inner, last. Okay, however, I will use the normal method of distributive property. It is the same, never change. A plus B, I will use like this. So you don't have to remember FOIL method. Plus C plus D. What we used to do, A multiplied in C and A multiplied in D. B multiplied in C and B multiplied in D. So the answer is AC plus AD plus BC plus BD. So in either way you use, you are correct. Okay, you don't have to remember the FOIL method. However, we have to mention it since it is in the book. Now let's take examples. Okay, examples. Okay, the first example, when we say multiply. Okay, so the first example is A. We say 7x minus 2 multiplied in 5x plus 4. So what we will do, we will multiply 7x into 5 and 7x also into 4. Also we will multiply minus 2 into 5x and minus 2 into 4. So our answer should be, this multiplication is equal to 7x multiplied in 5x is 35x squared, and 7x multiplied in 4 should be plus 28x, and minus 2 multiplied in 5x should be minus 10x, and minus 2 multiplied in 4 should be minus 8. So adding like terms, this should be 35x squared plus 18x minus 8. Another question. (4x plus 5 multiplied in 3x minus 7). So our solution should be, what we will do, we will multiply 4x into 3x and 4x into minus 7. Also we will multiply 5 into 3x and 5 into minus 7. So our answer should be 4x multiplied in 3x should be 12x squared, and 4x multiplied in minus 7 should be minus 28x. Now 5 multiplied in 3x should be plus 15x. 5 multiplied in minus 7 should be minus 35. So we will add like terms. So 12x squared will remain the same, minus 28x plus 15x is exactly minus 18x, and minus 35 will go down, and we are done for this question. So this is equal to 12x squared, and minus 28x plus 15x is equal to minus 13x. Minus 35 will remain the same, and we are done for this question. So another question, if it comes, let's say 2x minus 3y multiplied in 4x minus 5y. So what we will do right now, 2x multiplied in 4x, 2x multiplied in minus 5y, minus 3y multiplied in 4x, minus 3y multiplied in minus 5y. So our answer should be 2x multiplied in 4x is 8x squared. 2x multiplied in minus 5y is minus 10xy. Now minus 3y multiplied in 4x is minus 12yx. Okay, and minus 3y multiplied in minus 5y is plus 15y squared. Now we add like terms. Here we have minus 10xy and minus 12yx. They are like terms. This can be written also minus 12xy. This is okay. So they are like terms. So our answer should be 8x squared plus 15y squared minus 22xy. And you are done for this question. Let's now take another question. Let's say if we have 3a minus 5b multiplied in 4a minus 7b. So what we will do, we will multiply 3a into 4a and 3a into minus 7b. Also minus 5b into 4a and minus 5b into minus 7b. So our answer should be 3a multiplied in 4a is 12a squared, and 3a multiplied in minus 7b should be minus 21ab. What about minus 5b? Minus 5b multiplied in 4a is minus 20ba. Minus 5b multiplied in minus 7b should be plus 35b squared. So now we have to add like terms. Here minus 21ab and here minus 20ba. This can be written also minus 20ab. There is no problem with that. So these two are like terms. We should add them together. Now we say 12a squared plus 35b squared minus 21ab minus 20ba. So it should be minus 41ab, or ba, it is the same. So you are done for this question. Now let me introduce you to special product formulas. The first special form, if we say the sum multiplied in the difference. Okay, if we say for example x plus y multiplied in the difference x minus y. Okay, x plus y multiplied in x minus y. The second special form, if we say we have a binomial raised to the power 2. That is, if we have x plus y squared, what does this equal to? And also x minus y squared, what does this equal to? There are existing special product formulas. You should memorize them. Okay, what are they? The first, sum multiplied in the difference. If we say x plus y multiplied in x minus y, this is equal to x squared minus y squared. Okay, the second special form, if we say a binomial raised to the power squared. So when we say x plus y all to the power squared, this is equal to x squared and here plus y squared, and the sign in the middle we put it as it is, and plus what? 2xy. Also, if we have x minus y all raised to the power square, the same, x square here, and here we have plus y square, and the sign in the middle we put it, and the middle term is 2xy. So these are the special product formulas that you have to memorize. How did we get to these formulas? Guess what? For example, if we say the sum multiplied in the difference, we say x plus y multiplied in x minus y. This is equal to what? Using the distributive property, x here multiplied in x here, and x here multiplied in y here, and y here multiplied in x here, and y here multiplied in minus y. So x multiplied in x is x squared, and x multiplied in y is in minus y, it should be minus xy. So what about the y? Y multiplied in x is plus yx. What about y multiplied in minus y is minus y squared. So minus xy and plus xy, this yx can be written as xy. Okay, no problem with that. So these two are like terms. Minus xy and plus xy will eliminate each other. So we will have left x squared minus y squared, which is our first special formula. Now, what about x plus y all squared? This is equal to x plus y multiplied in x plus y. So using the distributive property, here multiplied in here, and here multiplied in here. This one multiplied in here, and this one multiplied in here. So x multiplied in x is x squared. X multiplied in y is plus xy. Now y multiplied in x is plus also yx, and y multiplied in y should be plus y squared. This yx can be written as xy. Yx or xy is the same. Like you say 3 multiplied in 2 is 2 multiplied in 3. Okay, you remember this property of the real numbers. What it is called? It is called the commutative property. The commutative property, x multiplied in y equals y multiplied in x. So completing our answer, this is equal to x squared xy plus yx is plus 2xy, and y squared will remain the same. So now we are having our second special product formula, which is this one. Okay, now what about x minus y all to the power squared? This is equal to x minus y multiplied in x minus y. So this is equal to x squared minus xy minus yx plus y squared. So this is eventually equal to x squared minus 2xy plus y squared, and we are getting our third special formula. And these formulas need to be memorized always. Okay, let's take examples. So our first example is 7x plus 10 multiplied in 7x minus 10. What does this equal to? If you see the two binomials, this binomial and this binomial, it is the sum multiplied with the difference. So using the sum into multiplied with the difference, we know it is x squared minus y squared. Okay, so this means the first term squared, 7x squared, minus the second term squared, which is 10 squared. This is equal to 49x squared minus 100. Okay, another example, if I say 2y squared plus 11z all to the power square. So our answer should be, we are using a binomial, raised to the power 2. We are here, okay? So it is the first term square plus 2 multiplied in the first term and the second term plus y squared. So this will be equal to the first term square, 2y squared all squared, plus 2 multiplied in the first term, 2y squared, multiplied in the second term, 11z, plus the second term squared. So this is equal to 4y to the power 4 plus 2 multiplied in 2 multiplied in 11. This means 44 y square z plus 11 square is 121 z square. Another question, if I say 4x squared minus 3y multiplied in 4x squared plus 3y. If you can see, it is the sum multiplied in the difference. So we can say the first term square minus the second term square. So it should be 4x squared all squared minus the second term square, which is 3y all squared. So this is equal to 16x to the power 4 minus 9y squared. Another question, if it comes like 3x minus 5y squared all to the power squared, all to the power squared. This is a binomial raised to the power 2, so it is the first element squared, 3x squared, here minus 2 multiplied in the first element, which is 3x, multiplied in the second element, which is 5y, plus the second term square, which is 5y, or 5y square, all to the power square. Here should be square. Here, because here it is square, the second term. So the final answer should be 9x squared. 2 multiplied in 3 multiplied in 5, it means 6 multiplied in 5 should be 30 xy squared plus 5 squared is 25, y squared to the power 2 is y to the power 4. Another question, if it comes like 4w plus z all to the power 2, this is a binomial with raised to the power 2, so it should be the first element squared plus 2 multiplied in the first element, 4w multiplied in z, plus the second element squared, z squared. So this is equal to 16w squared plus 2 multiplied in 4 is 8wz plus z squared. Another question, if it comes like 3x squared minus y all to the power 2, this is equal to what? The first element square should be 3x squared all squared minus 2 multiplied in the first element multiplied in the second element plus the second element square, which is y squared. So this is equal to 9x to the power 4 minus 6x squared y plus y squared. Another question, if it comes like 3x plus 5 multiplied in 3x minus 5, this is equal to what? We know that it is the sum multiplied in the difference, so the first element squared minus the second element or term square. So it should be Now 3x squared should be 9x to the power 2 minus 25. Another question, if it is x plus 5 plus y multiplied in x plus 5 minus y. You can see it is the sum multiplied in the difference. So the first element squared, it equals minus the second element square, or second term square. So the first element square is x plus 5 all squared minus the second element square, which is y squared. This is not in the simplest form. We should decompose it right now. What does this equal to? It is a binomial raised to the power 2. So this is a binomial raised to the power 2. We know it should be the first element square plus 2 multiplied in the first element multiplied in the second element plus the second element square, which is 5 square. Okay, so and this minus y will go down, so it is minus y squared, so will go down, so it is minus y squared. So it is equal to x squared 2 multiplied in x multiplied in 5 should be plus 10x plus 5 squared is 25 minus y squared. So we are done. The final thing to discuss in this chapter is to evaluate a polynomial. For example, if I say evaluate two x cubed minus 6x squared plus 7 for x equals minus 4. How to evaluate that? The way to evaluate is to substitute the given value. Substitute the given value, or if there is more than value given, substitute them all. Substitute whatever values are given. So to evaluate, now let's take this. So it should be, this one should be 2 multiplied in x cubed. X cubed is minus 4 to the power 3 minus 6 multiplied in x squared, so x minus 4 here square plus 7. This is equal to 2 multiplied in minus 64 minus 6 multiplied in 4 square is 16. 16 multiplied in 6 is 96. So it should be minus 96. Okay, plus 7. So the final answer should be minus 128 minus 96 plus 7, which is equal to minus 217. Okay, this is how do you evaluate. Another question, if it comes like evaluate minus x squared minus 5x plus 4 for x equals minus 5. So what do we do to evaluate? Here we have minus multiplied in x squared, which is minus 5 squared, minus 5 multiplied in x, which is minus 5, plus 4. This is equal to, here it is 25 multiplied in negative should be minus 25, and here minus 5 multiplied in minus 5 should be plus 25 plus 4. So this will eliminate this, and the answer should be 4, and you are done.